All right, everyone. Let's get some clarification on the problem that we did. I need to share my screen. Okay. All right, so the problem that we are looking at, how do I hide this? Okay, let's just put this. Okay, so this is the problem that we did in class. We didn't quite finish it, but we had some good discussions. I wanted to clarify a few things because we probably won't be able to go over it in class today. So I figured I would just post a video to make sure everyone is on the same page. Um, we've got this section here, and this section here, and we're just going to compare these three and to rank which one's bigger. So we're going to start by supposing f is continuous, positive, and decreasing, and that the series is equal to f of n, a function. So here I went ahead and made a function for us. This is f of x. I just called it 1 over x because it meets those three qualities of being continuous, positive, and decreasing. So we're going to play with this function today. You could do a different one, but this is what I've chosen. Now, Desmos has this cool feature where we can draw rectangles. The reason I'm drawing rectangles is because the problem asks us to draw a picture. Now, this integral here from 1 to 6, this represents the area under a curve. These are both series, and they don't necessarily represent area. What they do represent is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. Okay, and that is a value. However, because it asks us to draw a picture, rather than just writing those out, I'm going to visualize it. And the way that I'm visualizing it is by using rectangles or Riemann sum. Now, here in this set of rectangles, I have drawn a right-hand endpoint to represent this is our series, f of 1. We went to our value here and just made a rectangle with width 1. Because it has width 1, this rectangle is just representing a sub 1. This rectangle is a sub 2. We go to 2, we find the value, and then we give it a width 1, and so forth for the rest of them. Now, I can do this with this is a right-hand endpoint, but if I shift it over and look at this one, these are the same exact values, same rectangles, a sub 1, a sub 2, a sub 3, and so forth. But all I've done is I've shifted to use a left-hand endpoint. So we go up, and this is where we start our rectangle. But you'll notice these rectangles, 1, 2, 3, 4, 5, and these, 1, 2, 3, 4, 5, same. Same values, a sub 1 through a sub 5 added together. Okay, but I'm going to draw it on the right for visual purposes. If we use an actual function 1 over x, we could add up a sub n, a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and come to a value. We're supposed to compare this a sub 1 added up to a sub 5 with these other versions. So let's compare it first to this integral. We've got the integral of 1 to 6 f of x dx. Desmos gives us this answer. And if we add up the series, we get an answer that's greater. To make this into a picture, we're using our rectangles, and we can compare this to the area under the curve. So I'm going to turn this off real quick. So you can see this is our integral, 1 to 6 f of x dx. This is just the area underneath it. And these are our series values, a sub 1 through a sub 5, okay, added together. So not only can you see that the series is larger by comparing the numerical value of both of these, but if we look at them in terms of area, you can always see that these rectangles consistently poke out. So we know the relationship between this integral and this series. Where does this integral, or excuse me, where does this series fit in? Well, let's take a look at these tabs. So I've got this series represented with rectangles again. This series is just a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub 6. And that's what we've got here. We go to a sub 2, find that value, multiply it by 1 to make it into a rectangle. This is a sub 2, a sub 3, a sub 4, a sub 5, a sub 6. And just like the other ones, we could draw this. This is a left-hand endpoint. We could also draw this in a right-hand endpoint. For the picture's sake, I'm going to draw in a right-hand endpoint because I think it's very easy. Oh, sorry. I think it's very easy to compare to our integral. Um, as you can see, when we draw it with a right-hand endpoint, you can see it consistently fits underneath the integral. Also, we can check this with math. I have, again, the value of the integral here. Okay, here's it drawn. And then I've got the value of this series here, f of 2, f of 3, f of 4, f of 5, f of 6. And here is it drawn. And so by using this picture, we can easily see that this series is smaller than the area of the integral. I hope that this clears some things up for you. I hope that this helps to formulate this problem. This is kind of the visualization or the picture aspect. For your written homework, a picture like this would be a great reasoning tool. You could also back this up with math, but I hope that this will clear things up. I'm going to stop sharing and stop the recording. Thanks, everyone.